Number 12. We have force acting in the x direction. So look, I drew you guys a diagram so you can understand this. You got this force acting in the x direction on this object, this 2 kilogram object. Shh. It varies in time. So look, it's not a constant force. Look up here. Look up here. The force is not constant. So notice, like during the first 2 seconds, what's happening to the force? It's getting what? Bigger. So it's not a constant force. So then the force levels off. Then it gets smaller. But never, ever, ever does it point in the negative direction. Right? It's always a positive force. It's just not a constant positive force. Okay, so the first question is, from this graph here, what's the impulse? Now, what's impulse? Fancy name for change of momentum. Now, look, one of the equations for change of momentum, look at this right here. One of the equations for change of momentum, you take force multiplied by time. How do you find area? If you calculate area, notice what you're doing. You're multiplying what? Force and time. So the answer to the first question is going to be the area under the graph, right? So what you got to do, you're going to break it into 3 areas. Break it into 3. This first area right here is 4. This middle area, 4. This final area, 4. So what's the total area under the graph? 12. And then the unit for that is kilogram meter per second, which you could call a spaldo. So 12 spaldos. Okay? That's the impulse, change of momentum. Now, question B. What's the final velocity of the particle if it's initially at rest? So if this block starts here at rest, so now we're using this second equation here. So keep in mind, we know this now. What's that? 12. V initial, 0. So the way you do part B is you go, okay, change of momentum is mvf minus mv initial, just momentum final minus momentum initial. That's 0. So we're looking for V final, change of momentum over m. The change of momentum was 12 spaldos, kilogram meter per second. Over 2 what happens to the kilograms? They cancel and you get 6 meter per second. Bam. Okay, now last question. Find the final velocity of the particle if the so now the object has an initial velocity, so V initial is what? -2. What does negative mean? It's initially moving to the left, but keep in mind, the force is still to the right. The block starts out moving to the left, but the force is to the right. So what's going to happen to the block? It's going to go, the block's going to go like this. It's going to go slower, 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 stop, and then what? And then come back, right? Because the force is acting to the right. So how do we find out the final velocity? So change of momentum is mvf minus mv initial. Keep in mind this v initial right here is now what? -2. So what's going to happen to those negatives? They're going to cancel. Negative and negative gives a positive. So anyway, so v final is going to be change of momentum plus mv initial over m. So that's going to be 12 plus 2 times -2. I left the units off. Bad, bad, bad. I'm almost out of room, though. 2. Mass is 2. So this comes out as 4. If the initial velocity is 2 meters per second to the left, then the final velocity will be 4 meters per second to the right, because notice it comes out positive. Okay?